Hello guys, welcome to Aviation Weather Services 8.1 to 8.9 Gleim review and breakdown. So I'll just basically be explaining what the chapter went over. Um yeah, and if I get anything wrong, blame ChatGPT. That's what I used to help if I couldn't figure something out, okay? Anyways, um let's move myself over here. All right. Prior to all flights, pilots should get a weather briefing from the FSS, the Flight Service Station. FFS is not the ATC. I just want to make sure people understand that. But so when you want to get a weather briefing, you should identify yourself. So first, identify yourself as the pilot, your intended route, destination, whether you're flying visual flight rules or instrument flight rules, and the type of aircraft, and then your departure time and time en route. So like the amount of time between departure and landing, and that's not counting like your taxiway. And then I try to make a mnemonic for it, so please remember, don't forget the details: pilot, route, destination, flying, type, departure. But yeah, I'm sure if you're flying, you'll get the hang of it. Hang of it. Um, so the FSS weather specialists need to know which three types of briefing are appropriate. So like what type of briefing you need. So there's the standard briefing, which should be obtained before every flight. This briefing provides all necessary information. The outlook briefing, which is provided 6 or more hours before the proposed departure. So if you're like planning a trip later. And then the abbreviated. So when a user requests more information, you could request supplement mass dismated data, which I was like, what does that even mean? So I had to look it up, but it's provide extra information that's not already in the standard. Like, I don't know why they made that word so complicated, but whatever. Um, Update from a previous briefing and just any specific information, just limit it if you need something specific real quick. Anyways, question 1 for 8.1. To get a complete weather briefing for a planned flight, the pilot should request a general briefing, an abbreviated briefing, or a standard briefing. And they should get a standard briefing, okay? Also, just pause the video at each time there's a question so you can answer it first. But make sure you just don't mix it up with general and standard. I don't know. I got this thing straight from the Gleim and I messed it up. So I was like, damn, that's a little tricky. Um, 8.2 Aviation Routine Weather Reports or METARs. So there are two types of the METAR. There's the routine report that usually happens every hour, and then there's the special one. So it's non-routine weather report issued when significant weather conditions are observed between the 1 hour METAR cycles. And then this is what an example of a METAR is going to look like down here, and we will go over that. All right. So first off, first thing in the METAR is the four-letter ICAO station identifier, aka the four-letter like airport identifier. So we got KLX, which is the Los Angeles International, and if there's a K before the three other digits, that means it's in the US, like in the 48 states, not including Alaska and Hawaii. So that's just good to know what the K means. You're still in America. Um, then the date and time of the report ending with a zero to indicate the coordinated universal time. So it would be for the date it's saying here it's the 25th month or the 25th day of the month at 17:21 universal time. So yeah. Um so now we get the wind, which is a 5-digit group, 6 digits if the wind is greater than 99 knots, ending with KT to indicate knots for wind speed. If the wind is gusty, a G will be reported following the speed of the gust reported. So, um, so the first three digits here, 117, will be the true heading from north that the wind is coming from, so 117 degrees. And then the 14 next to it will be the knots, so 14 knot winds, and then gusts of 18 knots. So that's what the G stands for. So yeah. The greatest visibility reported in statute miles S ending with SM. So this is just the visibility report. So 1.5 SM would mean 1.5 statute miles of visibility. This is good to make sure you know if it's VFR or IFR conditions. Um, Next would be a weather phenomenon reported as abbreviations of a phenomenon. So symbols before the abbreviation will show you the severity. So if there's a minus, the severity is light. If there's no sign, it's moderate, and if it's a plus, it's heavy. Um, and it's usually within 5 to 10 miles from the reporting station that like these phenomenons are happening. Um, or if it has the VC. I don't remember, gang, but whatever. So, anyways, so a minus RA, RA stands for rain, and since there's a minus right there, that means it is light in the severity ranking. So, next we'll have the sky conditions. The ceiling is the lowest broken or overcast layer, or the vertical visibility into an obstruction. The cloud base is reported in 3 digits of hundreds of feet AGL. So, BKN stands for broken, and we have a 110 and a 010, which would mean 1,000 feet. And then you could do like a space in between that, and we have overcast here and overcast at 700 feet. Um, so yeah, basically this number, put in 2 more zeros after it, and you're chilling. Then you'll have the temperature, and then there will be a dash in between it, and the dew point. They're both reported in 2 digit forms in the degrees of Celsius, so you can know if you're like expecting rain with that. So yeah, we have a 2-16, which means the temperature is 20 degrees Celsius and the dew point is 18 degrees Celsius. And then finally, you'll have what you should set your altimeter to. So, A will be right in front of it, showing that it's the altimeter setting, and then it will be like here we got 2905, so you would set your altimeter to 29.05 in inches of mercury. That's just how you measure your altimeter. Oh, actually, and there's remarks. So the remarks is literally anything else. There's a bunch of remarks, so you're just gonna have to learn along the way, I guess. But here's an example. Remark RAB 30. So rain, RA, B began 30 minutes ago. I think that's a pretty common remark that you might get. Anyways. Alright, so a full example here. You're gonna get the METAR, KLX, 12th day of the month at 1852 Universal Time. Okay? Here at 250 degrees true north, the wind heading at 4 knots. You have 6 statute miles of visibility. BR is mist. It's brume in French, which means mist, but you can remember it by saying baby rain. Then we have scattered cloud cover at 700 feet AGL, and then scattered cloud cover again at 25,000 feet AGL. And then the dew point and the temperature. So first is temperature. So the temperature is 16 degrees Celsius and the dew point is 15 degrees Celsius. And then you would set your altimeter to 29901. So yeah, that is basically how you would read a report. I know it's a lot, but whatever. All right. So take a minute to pause. I'm not going to read all of these out because that'll be crazy, but which reporting stations would have VFR weather out of all of these? And the answer is KINK, KBOI, and KLAX. So the first three here you can see because of the statute miles and visibility. These two have less than 3 statute miles of visibility, so it wouldn't be VFR conditions. All right. AIRP aircraft reports. So they are reported routine or special, either reported by a pilot or generated automatically. PIRP reports are pilot weather reports, where are like the pilot generated reports, and the PREP I think is more common. So down here is kind of what one would look like. there's a lot of similarities to the METAR, so like it will kind of add on to it, but then there's a little more things to it. So okay, so all restarts will either start with a UA or a UAA. A UA is a routine low-level wind shear reports with an airspeed of less than 10 knots, and then a UAA would be urgent, weather reporting potentially hazardous to flight operations, so tornadoes, extreme turbulence, and severe icing. Also, the pilots will make this like if they want to, I think. Like they don't have to. If they feel like it, they want to report on something interesting that's happening. Because communicating between two pilots is the best way to learn um like what the actual conditions up there are. So anyways, so you'll start or one of them will be dash FL, which will be flight level. So it's in 3 digits for hundreds of feet. All heights are given in MSL. To determine AGL, subtract the field height from the given height. So FL 060 would be a flight level of 6,000. So that's you're stating where your plane is at altitude wise in the sky. Yeah. Next we have slash TB, which is turbulence. So turbulence can be ranked with intensity and type. So the intensity can be light, LGT, moderate, MDT, severe, SVR, and extreme, EXTR. And then this is like extreme is worse than severe. Okay. And then the type. So there's cat, which is clear air turbulence. So turbulence you can't see. And then chop, which is like choppy or rhythmic, like sort of turbulence that just like keeps happening. And then OCNL would mean occasional turbulence. If you're reporting turbulence on a different altitude than your current flight level, include the altitude that the turbulence was at. So anyways, an example would be slash TB OCNL LGT dash NDT BL 0 BLOW 090. So what that's translated to, it's a mouthful, is turbulence here, occasionally light to moderate below 9,000 feet MSL. That's what the below stands for right there. Don't get it confused with like blowing winds or something. It means below. Okay, slash IC, which is so that's icing. Ice is ranked by type and intensity, just like turbulence. So the intensity scale is the same, and then type, you can either have clear, so icing that's clear and pretty like sheer, and then rim, which is like this kind of more like glossy, bumpy, and it's like kind of appears more milky um on your wings. So those are the two types. I don't know why I didn't have an example. Oops. But anyways, slash WV is the wind. So wind is a 5 or 6 digit code, just like how it was in the METAR. Starting with 3 digits of direct wind that is that is blowing and a 2 digit code for the wind speed and 3 digits if more than 99 knots. Then is ended with KT. So slash WV 130 45 kT means wind is coming from 130 degrees and blowing at 45 knots. So pretty simple, just like how it was in 8.1. And then slash TA is the temperature. Temperature is reported in degrees Celsius. If the temperature is less than 0, an M should be added before the temperature. Temperature should be reported if icing is occurring. So slash TMM06 would be a -6 because we have the M in front. So -6 degrees. Now we have the slash OV, and I figured out that there's like kind of two ways to show this. So it's the location, it's your location report, a 3 or 4 digit code of the closest airport or VHF NAVAID, so navigation aid. And you have two options of doing this. So option A, you can insert the navigation aid you're going to using a dash just so that you're between these two navigation points. So point A and point B, and you're in the middle, then you just put a dash, okay? Or you can use a 6 digit code to show your radial from the navigation aid. So the first 3 digits is how many nautical uh is the radial of the nautical mile sorry. It's the radial degrees that you're away from it. and then you add how many nautical miles away you're from the navigation aid. So basically, slash OV would be so you have your navigation aid here, and then 090, which would be 90 degrees radial, which is east. So you're east of that navigation point, and then 20 nautical miles away from the navigation aid, if that makes sense fully. Um, so S slash SK is sky. So sky cover, report cloud amount, height of bases, and height of cloud tops. Unknown information, use unknown. It's pretty similar to how it was reported in the METARs. But anyways, so the format where you do S slash SK, and then you do sky cover, then the layer base, and then the layer top, like dash layer top, and then you put in a slash if there happens to be another cloud layer, and then you would put in the next cloud layer, next layer base, and next layer top, or next sky cover. So each layer is separated by a slash that I have right here. Oh, and then it can either be broken, overcast, or scattered. Um, so here's an example. SK, SCT scattered, so from 15,000 feet, and then the top um would be at 3,000 feet, and then broken at 8,000 feet, and the top is unknown. So that's how you report upon it. Slash WX would be flight visibility and weather. First, you will start with your flight visibility with an FV, followed by the 2 digits of the statute miles that are visible. Then end it with SM to indicate it's measured in statute miles. Second, you'll report weather. Start with weather intensity symbols if the weather is classified as precipitation. So if it's like raining or snowing or something like that, you would do the light, moderate, heavy thing. Then add the abbreviation of the weather phenomena. So dash WXFV 05 SM. So that's 5 statute miles with light rain. So yeah. And then speed run here. Slash TM is the time. So you put in the 4 digits of the central time. So slash TM 1309er would be 13.09 clock or whatever. Slash TP would be the type of aircraft. All aircraft will have no more than a 4-digit code. And if you don't know your code, just put unknown. So slash TPC 172 would be a Cessna 172. And then slash RM is just like the remarks, which would be other information. So slash RM LLWS minus 15 KT SFC 030 DURGC R22 JFK. That's a lot. But what we're saying is LLWS is low level wind shear, loss of 15 knots between the surface and 3,000 feet. That's why we got the subtraction here. AGL, during climb, DUGC, or it can be during landing, which would be DULC. So during climb from runway RY 22 at JFK. So it's a lot. But you will start to understand, hopefully. All right, question. Refer to this report. Also, you're gonna need a calculator for this question. I hate reading that out to you, gang, I'm not gonna lie. But if the terrain elevation is 1,295 feet MSL, what is the height above ground level of the base of the ceiling? So, and the answer is 500 feet AGL, because you want to subtract this with, where is it? Height above, so the ceiling, so the cloud ceiling, which would be here, so 18,000 feet, minus this is 505, I think. All right, 8.4, Terminal Aerodrome Forecast, TAFs, which is a weather forecast for selected airports throughout the country. It covers up to 5 statute miles from the airport and is updated every 6 hours. TAFs are consistent of 5 different elements that they report on. So they'll report on TAF or TAF AMD, which is the amended forecast. They're amending the original one. The ICAO station identifier, so the airport that the forecast belongs to. The date and the date the forecast was prepared, the valid period of the forecast, and then meteorological conditions like wind, visibility, weather, sky conditions, and the only clouds that they report on, by the way, are cumulonimbus clouds, okay? So, an example of a TAF, and I only highlighted the stuff that we haven't gone over. The rest should relate to the METAR. So TAF KDN, so that means the forecast was for Denver International Airport, 04130Z. So prepared on the 4th day of the month at 11:30 UTC, and then is valid from 12 UTC on the 4th to the 16th on the 4th, or to 1600 on the 4th. And then from the 4th day, 18 UTC. So like this is like an update on. So from this time to this time, or at this time, these become true now, and then at this time, these become true. If that makes sense. Like that's like later in the day. Look out for that, okay? I sorry. This is so hard to explain, but I'm trying my best. So, anyways, refer to this TAF. During the period from 060Z to 0800Z, what is the visibility forecast for KOKC? So pause it, take a look, and the answer is greater than 6 statute miles. And if you couldn't find it, let's find this together, because I don't remember. Um, So we have to find the time period. So let's find the FRO. So FMO from 1600 to, and then is there another FMO? FMRO? I don't think so. I don't think so. Okay. So then we go look at the statute miles, and it is right here, which is 6 statute miles. And the P, um, you might have gotten tricked up and say that it's possibly, but P stands for more like plus, so it'd be greater than 6 statute miles. All right. Radar, weather reports, SD/ROB. That's what they're like called, I guess. Reports of weather and radar information. This will include the type, intensity, location of cell movement of precipitation. The intensity trend of increasing or weakening is no longer added to the report. I don't know, the Gleim really wanted you to know that for some reason, but yeah. So you'll no longer know if the if the storm's weakening or increasing, I guess. But anyways, there really was nothing on it. There was only one question. So radar weather reports are of special interest to pilots because they indicate large areas of low ceilings and fog, location of precipitation with type, intensity, and cell movement of precipitation, and location of precipitation along with type, intensity, and trend. The answer is B, location of precipitation along with the type, intensity, and cell movement of the precipitation. That's basically all I said in the slide before, so hopefully you got that. Anyways, 8.6. Um, I'm just gonna compare what the difference between these two are, but it's basically going over the flight service station and the flight information service broadcast. So for the FSS, that is provided by a human, and you are you access it on uh 122.2 radio, and you need two-way communication for this because you're talking to someone else. So it's a weather briefing that's tailored to your flight plans, and then you get NOTAMs, PIRAPs, and altimeter settings, and it updates on request. So basically, you call in, you tell them your route, and then they kind of just go over all the weather with you. Um, so that's what the FSS is. And then the Flight Information Service Broadcast is an automated data broadcaster over the ADS-B. So you'll need an ADS-B via the 978 MH. So it's one-way communication. You're not talking to anyone. So it's just continuously broadcasting weather. So AirMets, all SIGMETs, NextRad, NOTAMs, METARs, TAFs, winds, PIRAPs, and special airspace updates. So It's not specifically tailored to you, but it will continuously tell you what's going on in the area. And I think a lot more people use this. Well, at least what my professor said, that was like, these guys are kind of amazing. Like they'll tell you exactly what this says. So, anyways, it updates every few minutes. The next rad may be updated every like 20 minutes, like old. So don't use it to navigate severe weather. Use something else, I guess. Anyways, question 6. How should contact be established with a FFS or FSS? And what service would be expected? So call flight service on 122.2 for routine weather, current reports on hazardous weather and altimeter settings. Call flight assistance on 122.5 for advisory service pertaining to severe weather. Call flight service on 122 for information regarding actual weather and thunderstorms activity along proposed route. So the answer is A. Call flight service on 122.2 for routine weather, current reports on hazardous weather and altimeter settings. And basically, the like description of these are like somewhat right, but what you need to look at is what we're calling them on, and 1.22.2 is the only correct one. So yeah. All right, I gotta move my thing because I want you to be able to see this up here. So wind and temperature aloft forecast or FB. So wind and temperature is provided for specific altitudes for specific locations in the US. So here you can see that we got 3,000 feet for DN, so like 3,000 feet, probably Denver, I guess. And then, and it just provides you the specific altitude. So here we got 30,000 feet for the same place. So it's a 6-digit code that includes wind directions with reference to true north and wind speed in knots and a temperature in Celsius. So the format would be the wind direction with a 0 added at the end, like you would add an imaginary 0 at the end, so that's 2 of the digits, and then the wind speed, which is the other 2 digits, and a temperature with a plus or minus to indicate if it's below freezing or not. So 2332.02 would be the wind direction is coming from 230 degrees, 32 knots, and it's 2 degrees Celsius out because it's a plus. So if there was a minus, it would be negative 2 degrees Celsius. And then little add-ons about this. There's a couple weird things about it. So if the wind speed is less than 5 knots, the forecast will be coded as 9900, which just means wind is light and variable. So above 25,000 feet, the temperature is always negative. So if you go back and look, they stop adding the plus and minus signs because no matter what, the temperature over here will be negative. No temperature is forecasted for altitudes lower than 3,000 feet. You can see that right here. No temperature forecasted. If the wind speed is over 100 knots, forecaster adds 50 to the direction and subtracts 100 from the wind speed. So that's really weird. I hate that they do that. But anyways, you'll know because this number right here will be too big to be, it will be more than 360, so it wouldn't work. So anyways, so if we had 7507 minus 49, the wind direction would be 25, or 250 because we subtract 50 from the 75. And then the wind speed would be 108 knots. That's a typo. It should be 107, but that's because it'd just be 7 plus 100, and then negative 94 degrees Celsius, which we have right there. All right. When the term light and variable is used in a reference to winds aloft forecast, the coded group and wind speed is A, 4 zeros and less than 5 knots, 9900 and less than 5 knots, 499ers and then less than 10 knots. And the answer is 9900 and less than 5 knots. Because if we go back, that's what I was talking about right here. All right, now we got the SIGWICS, significant weather charts. So when you will open this up and look at it, there will be 2 panels. So panel 1 will be the forecast conditions for the 12 hours, like first general 12 hours, and then panel 2 will be for the whole entire day, so 24 hours. So you'll use these charts to determine areas to avoid freezing levels and turbulence. So how you use this chart, okay, yeah. How you use this chart is these lines will indicate to you what everything means. So if there's a red line, like right here, the ceiling is less than 1,000 feet and or visibility is less than 3 miles. So red line would mean IFR, it's not VFR conditions anymore, it's not safe. If you see a cap like this, that means there is turbulence in that little section. And then there will also be a number. So the number will mean like what level that is at. So it's in hundreds of feet, so this would be 24,000 feet with a base of 10,000 feet. So whatever it's indicating there would be in between those two levels. I couldn't find that good of a picture to show you, but here is a little bit better. You can see at 8,000 feet there is light turbulence right there. But anyways, um, at what altitude is freezing levels over the middle of Florida on the 12-hour significant to weather prognostic chart? And if you don't live in America, I guess, but Florida is right here. It's right here. Um, and the answer is 12,000 feet because we can see that right here and right here. This is actually the one we should be looking at. 12,000 feet. All right, air 8.9. So we got the air mets and the sig mets. So they notify pilots of possible flying hazardous flying conditions. So air mets will really only apply to light aircraft. Well, I mean, it applies to all aircraft, but it's like concerning to light aircraft, and you should look at that. So like single engine aircraft. And then SIGMETs apply to all aircraft. And I kind of remember that like SIGMETs, like the S means like, to me, like means like severe. And like airmets are like less severe. So anyways, there's convective SIGMETs and then just like normal SIGMETs, like non-convective. So convective SIGMETs will have tornadoes, lines of thunderstorms, so like squall lines, embedded thunderstorms, thunderstorms areas greater than or equal to the thunderstorm intensity level 4, and apparently they in aviation they rank it from 1 to 6, and then with an area coverage of 40% or more, and then hail greater than or equal to 3/4 inches in diameter. And then a non-convective, so like non-storm like shit would be, oh sorry, non-storm like stuff would be severe turbulence or clear air turbulence not associated with a thunderstorm, severe icing not associated with a thunderstorm, dust storms, sandstorms, volcano ash lowering visibility to less than 3 statute miles. Also, look out for volcano ash. I've listened to this amazing plane crash document. Oh, it wasn't a plane crash. They didn't crash, but that ash can stuff up your engine, okay? And then volcanic eruption. And then the air mets, so they're divided into 3 groups. We have Zulu, oops, that's a typo, but Zulu, Tango, and Sierra. So what the air mets go over would be moderate icing, which is on Zulu, um, moderate turbulence, Tango, visibility less than 3 miles, or ceiling less than 1,000 feet. This should be 1,000. Should be Sierra. Sustained winds of 30 knots or more, which is Tango, and extensive mountain obscurement, which is Sierra. So I think like Sierra is kind of like visibility stuff, and Tango is kind of like turbulence and wind, I guess. I don't know. But to get the full picture of weather conditions for air mets, refer to Zulu, Tango, and Sierra. Just look at all of them. And air mets should be used to determine freezing level of probable icing. Oh, freezing level and areas of probable icing. So, which in-flight advisory would contain information about severe icing not associated with thunderstorm? Okay, sorry, there's so many typos. I got excited that I was finishing my presentation. But anyways, so we got convective SIGMET, SIGMET, or airmet. And it would be SIGMET. Since it's not associated with a thunderstorm, it wouldn't be convective, and since it's severe, it would be a SIGMET. So anyways, it was a lot of information. If I get anything wrong, leave a hate comment. And I'm not a professor and I'm low-key not even a pilot, but this is just what helps me study. So anyways, I hope you found it useful. Thanks for watching.